In this graph, I want to talk a little bit about how we could use the graph to help us come up with the solution to our inequality. The inequality that we started with was the absolute value of 2x minus 1 is greater than 11. And the correct answer or solution was given as minus infinity to minus 5 and 6 to infinity. But I want to look at how this graph shows us that. So in the graph, you can see what we have here in red is the absolute value of 2x minus 1. It's that function. And what we have here in blue is y equals 11. So notice that where these two functions intersect is at the point -5, x equals -5, and also at x equals 6, okay? So we can see that those things are a part of it. If this problem had said the absolute value of 2x minus 1 equals 11, we would see that solution on this graph. It would be at -5 and also at 6, x equals 6. Okay, but notice also that besides the equals part, we have a portion of the absolute value graph that falls below y equals 11, or it is less than y equals 11. There's also a portion that falls above y equals 11. Actually, two separate portions, okay? So there are a couple of things that we can get from this. Let's talk about the less than part first. Notice here, let me see if I can get a little something to help us see. Notice the part that's less than. I'm going to try to outline it, right? This is this portion of the graph from -5 to +6. This portion that I have highlighted here falls below 11, okay? It's less than 11. Notice, I'm going to fade this out a little bit. Okay. Notice that the x values where this happens ends up being one continuous range, right? It's from -5 all the way over to 6 without any breaks, okay? From -5 to 6, excluding -5 and 6, because we know that's where it's exactly equals to. But between -5 and +6, our absolute value function is less than y equals 11. It has one continuous range where it's less than. Okay, so if I wanted to talk about where this thing was less than, I would say from -5, comma, to 6. Okay, but for the greater than portion, notice that it is two different pieces, right? It's greater than, and I'm starting over here on the left side, it's greater than from -5 all the way out to minus infinity. Okay, once we get over here, the absolute value function, remember we're looking at the blue line and the red line. So for values that are less than -5, it's going to be, the absolute value function is greater than 11. All right, from -5 to minus infinity, or minus infinity to -5. Also, you see it happening, Control Z. You see it happening here, starting at 6 to infinity, right? The graph is going to be greater than, the absolute value is greater than 11 for values of x from 6 to infinity. Notice that this happens with two different, or two, we'd say disjoint pieces of the graph. It goes from minus infinity to minus 5. That's the x values over here. And then we pick it up again from 6 to infinity. So one, we can see the solution when we look at a graph like this. Two, it should help us also understand why, if we're talking about less than, it's going to be one continuous solution. And if it's greater than, this is why we write it this way. This is another way for us to look at it, looking at an actual absolute value function and a constant, right? For that part that's going to be greater than, it's going to happen in two different pieces, okay? That's my response.